Voyager 1 is 16 billion miles from Earth. Every signal it sends takes almost a full day to arrive, which means on February 27, 2026, when its power began crashing toward a shutdown threshold, the team on the ground didn't find out until the crisis was already almost a day old. Cross that threshold, and the spacecraft's own computer decides something's wrong and shuts itself down. Alone. With nobody able to stop it or even see it happening in real time. It didn't cross the line, not that day, but it came close enough that 7 weeks later, NASA switched off one of Voyager 1's last 3 working science instruments, on purpose, just to buy some breathing room. This is the spacecraft that took the pale blue dot photo, Earth as a speck of dust in a sunbeam shot from 4 billion miles out. Bolted to its side, a golden record, greetings in 55 languages, whale song, Bach, built for whoever, whatever, eventually finds it. Its twin, Voyager 2, shows up once in this story, as the test case for the fix that might save it. Both launched in 1977, 16 days apart. Voyager 1 took the faster route, past its sibling, and reached interstellar space first in 2012. Both run on the same kind of generator, a chunk of decaying plutonium turning heat into electricity. No sunlight worth using out here. No refueling, ever. And every year, without exception, that generator loses about 4 watts. A dim light bulb's worth. Non-negotiable. For over 3 decades, that's meant one thing: the Voyager team quietly switching its own spacecraft off, piece by piece. 10 instruments each at launch, 7 already gone by the start of this year. The February scare made the math worse than planned. On April 17th, engineers sent the command to kill the 8th, the Low-Energy Charged Particles Instrument, LECP, which had been measuring cosmic rays and solar particles almost without interruption since 1977. 49 years of continuous data cut off midstream to keep the fuel lines from freezing. That left 2. It bought about a year. Time the team spent finishing something they'd been quietly building for over 12 months. Something with a name that should probably worry you a little. They called it the Big Bang. A strange name for a plan to save a spacecraft, but it's honest about what's at stake. Here's the actual problem. Switching things off one at a time was running out of road. Worse, some of that power wasn't being wasted at all. It was heat, keeping fuel lines from freezing at nearly minus 270 degrees Celsius, 3 degrees above absolute zero. Cut the wrong thing, even to save power, and you freeze the spacecraft solid trying to keep it alive. So instead of one change at a time, the team designed something riskier. Flip several systems in the same instant. Kill 2 heaters and an old tape recorder that had only stayed powered for the heat it gave off. Switch on lower power replacements at that exact moment so the thermal balance never actually breaks. All calculated from documentation written in the 1970s, numbers the team had quietly stopped trusting. If the documentation says 4 watts and it's really 3.8, project manager Suzanne Dodd explained, that's the difference. At this distance, 0.2 of a watt isn't a rounding error, it's the whole plan. Mission manager Kareem Badarudin, more bluntly, we couldn't afford to be wrong. Voyager 2 went first, closer to Earth, more power in reserve, lower stakes if it failed. It cleared its tests that spring. The permanent switch came July 9th, then 36 hours of waiting to find out if the model held. August 4th, NASA confirmed it worked. All 3 of Voyager 2's remaining instruments still running. Almost 10 extra watts freed up, enough to push its next forced shutdown out by roughly 2 years. Voyager 1 is next, and Voyager 1 is worse off. Farther out, down to 2 instruments instead of 3, and according to the team's own account, no longer behaving quite like a machine built from the same blueprint as its twin. The first checkpoint, the power test, passed at the end of July. The second checkpoint, the thermal test, the one that actually decides whether Voyager 1 survives its own rescue, is happening within days of this video going up. Nobody running the mission knows the answer yet. Neither do we. If it works, there's a real chance that instrument comes back online. Not a replacement, the same physical instrument, resuming a measurement it started under a different president in a different America 49 years ago. If it doesn't, Dodd's own read on it, as blunt as anyone at NASA gets, the team may be down to its last few tricks for buying this mission more time. Voyager 1, 16 billion miles out. Its survival, right now, depends on whether numbers written before most of its own engineers were born are still accurate to 0.2 of a watt. Whatever the answer is, it's already been decided. We just haven't heard it yet.